Okay, Math 10s, we're moving on to lesson 3 in the unit of numbers and exponents, and this is going to be on page 17 of your workbook. This lesson, we're taking a shift from what we did in the last two lessons. So the last two lessons was something called prime factorization, and what we're going to be doing in lesson 3 and lesson 4 is we're moving to the number system. So what I'd like you to do, I'm going to give you a small bit of notes, and I want you to write at the top of your page on page 17. So what happens is if I throw any number at you, all numbers that exist in our course, like in Math 10, Math 20-1, 30-1, we call them real numbers. Okay? And those real numbers are divided into two categories. So all numbers are classified as what's going to be real numbers. And then from there, numbers are either going to be rational or irrational. And you may have learned about rational and irrational in grade 9. You have to have a really good understanding of it in grade 10. And what's going to happen by the end of this lesson, like I said, is I'll throw any number at you, and you'll first say to me, okay, it's a real number. But then you quickly have to be able to tell me if that number is rational or irrational. But there's some little tricks and things that I will teach you. So the first thing for rational numbers, and this is probably the most important, all fractions are going to be rational. So if I give you a number and it is a fraction, like this guy here, and I said, okay, well, what would 28 over 11 be without even looking at it, what the decimal is? You'd first say, okay, that's going to be a real number, and you'd be correct. And then it is either going to be rational or irrational. If this guy is a fraction, it is going to be rational. Then what happens with rational numbers is something happens to their decimals. So if I type this on my calculator, 28 divided by 11, let's look at the decimal of this. 2.54545454. This decimal is what's called repeating, okay? And rational numbers, their decimals could repeat. Decimals repeat. So for example, 1/3. If I gave you this number, you would say to me, it's a fraction, Mrs. King. Therefore, it has to be rational. And you'd be right. This is a rational number. If you type this on your calculator, you're going to get 0.3 repeating. That guy is a rational number. Okay? Now, the other thing about rational numbers, write down the number 1/4. So write down 1 over 4. If you type that into your calculator, you're going to get 0.25. Now, this is a fraction, so we know that it's rational, but what is special about the decimal is it's what's called terminating. So rational numbers, their decimals either repeat or they terminate. Or write down decimals terminate. Okay? That's what you need to know for rational. The rational numbers, I always call them the nice, clean numbers, right? Their decimals either terminate or they repeat. Irrational numbers, these guys are ugly. And why are they ugly? Okay, so first of all, there's two famous irrational numbers. Actually, the most famous irrational number of all is pi. This guy is irrational because if you look at its decimal, what I'll do is the pi button, it's right above the little hat here. So if you hit second function, that hat, you'll get pi. This decimal, it never terminates and it never repeats. That is irrational. So pi, is to memorize, is the square root of 2. So if you look at the square root of 2, it's ugly. That decimal never terminates and it never repeats. It is irrational. So the clue for irrational is decimals. Two things have to happen. They never terminate and they never repeat, right? Because if they repeat, they're going to be irrational. Okay, something really interesting that your calculators will do, and this is where students that have the graphing calculators have a bit of an advantage, and the students that don't have graphing calculators, you really need to go get your parents to buy you like the TI-84 calculator. So the one that I use here, this is a TI-84 Plus CE. You could get this at Staples, at Walmart. This is a color calculator. You need this graphing calculator, okay? Okay, so here's the advantage of this calculator. Let's say I gave you this number here, 0.26, and I said, okay, is that rational or is that irrational? You would say, well, it's terminating. It's nice, right? It's terminating. That guy there is going to be rational, and you'd be correct. But look at what your calculator can do. You can type in 0.26, then you hit this math button. You're going to use a ton of things under this math button. If you hit number one, fraction, and then hit enter, it will convert your decimal into a fraction. So 0.26 is 13 over 50, and any fractions are rational numbers, right? Let's say I said the number square root of 25. Is that rational or irrational? So you would say, okay, square root of 25 is 5. And again, to turn that into a fraction, any number over 1 would be a fraction. But what if I said the square root of 3? Okay, so let's look at the square root of 3. Square root of 3. It doesn't look like it terminates, and it doesn't look like it repeats, but just to double check, always hit math 1 fraction. It will go into a fraction if it's rational. So the square root of 3 is irrational. Okay? Let's do class example number 1. What we're going to do is we're going to quickly go through all of these, and we're going to state if it's rational or irrational, and then we're going to talk about their decimals. So without even typing oh, and you guys remember all of these are real, right? So real, 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 real. But now with the real numbers, they're either rational or irrational. I know that these three are rational without even looking at their decimals because they're fractions. This guy I know is rational as well because this is 0.94444. It repeats. So this guy is rational. Write down decimal repeats. And let's check what this is as a fraction. So take out your calculators. 0.9, enter a whole bunch of 4s. Math, 1 fraction, and you get 17 over 18. So look at that. All fractions are rational. Square root of 8. It looks like it never terminates or repeats. Let's check. Math 1 fraction. It does not go into a fraction. This guy is irrational. Square root of 0.16. Square root 0.16. Nice terminating decimal. I know that's going to be rational, but let's figure out what the fraction is. Math 1 fraction, 2/5. So 0.4, which is equal to 2 over 5. This guy is rational. Decimal terminates. Okay, let's look at all of these three. So for A, 1 over 8. Terminating decimal. So write down 0.125 and then write down decimal terminates. Let's figure out 2 over 11. 1, 8, 1, 8, 1, 8, 1, 8, 1, 8. 1, 8 with a bar over top. Decimal repeats. Okay, this one is interesting. So we're going to start this one. We know, you guys, that this is rational, right? If it is a fraction, 100% of fractions are going to be rational. So the decimal is either going to terminate or repeat. But this decimal scares kids, and I'll show you why. Type in 9 divided by 7 on your calculator. When students see this, at first glance, they would say, wait a second, isn't that irrational? Like, it looks like it's going to go on forever, and it looks like it doesn't repeat. It actually does repeat, and there's a big repeat. Here's what it is: 285714. 28, this would be a 5714. If my calculator could go on forever, the repeat would be 285714. 285714, 285714. What your calculator does, if it repeats, is it will round this number up, right? So it rounded the 5 to a 6, but it is repeating 285714, 285714, 285714. So this one, the decimal repeats. Um, it's interesting, like when I could always tell my students who really get this versus who really doesn't, because on a test, the students that really get this, they will say, just looking at this, that it's rational. Students that don't quite get it, we're going to type this into their calculator, and then that number is going to scare them, and then they're going to second guess themselves and say, oh, maybe it's irrational, and they'll write irrational down. But remember, all fractions are rational. Okay, let's do class example number 2. Identify each of the following numbers as rational or irrational, and then give a reason. So reason has to do with the decimal. Terminates. What is terminating? Anything that terminates or repeats is rational. So I hope you guys see that that's rational. To check this on my calculator, 1.493, 1.493, math 1 fraction is 1,493 over 1,000. Okay. Square root of 5, you could type it in, the square root of 5, and you could hit math 1 fraction. It's an ugly number. The decimal never terminates or repeats. This guy is irrational. And talk about the decimal. Never terminates or repeats. Okay, let's look at this guy. 2.347, 347, 347, 347 goes on and on forever. I could rewrite this as this, 347 repeating. So please write rational and then write about the decimal. Decimal repeats. Negative square root of 81. So the first thing, to type this in on your calculator, this is your negative button, this is your minus. You must type in the negative button. Second function, square root of 81, that is the same thing as negative 9. And any number like that could be written over 1. It is rational. Oh, as a decimal, that would be like negative 9.0. Decimal terminates. Square root of 441. What would you guys say? Rational or irrational? So think about that. Does that decimal, is that a nice number or an ugly number? That is nice. The decimal terminates. Math 1 fraction, 21 over 10. 2.1, which is 21 over 10. This is rational. Decimal terminates. This last guy, it's a little bit tricky. Negative 0.8, 1122, 111, 222, 1111, 22222. So there's a pattern, but it is not terminating, like it's going to go on forever, but there's no repeats in here. So this guy here would be irrational. And what are the 2 reasons? It is non-terminating, right? It goes on forever, and no repeats. There is a pattern, but there's no repeats. Okay, the last type of question you'd have to do is question number 3. I always tell students to star this question. This is a really good test question. And they're questions involving number lines. I'm going to give you this trick or this hint. If you do this, you'll get this question right every single time. I always tell my students to think of money. Okay, so what do I mean by thinking of money? The square root of 14, I have no idea how much money that is. So let's clear our calculators and type in the square root of 14. That would be $3.74, right? Don't worry about all the other decimals, just how much money would this be? So that number is approximately you write an equals and then a little dot above it, $3.74. So then I go to my number line, and that would be approximately right about here. But I don't write $3.74 there. I write what they originally gave me, which was the square root of 14. Pi is approximately $3.14. If you forget, it'll always be on your calculator. So there's the pi button. So second function pi, $3.14. And that is less than $3.74. So I'm going to put pi here. Okay, let's figure out how much money the square root of 80 is. So square root of 80 is $8.94. So it's approximately $8.94. I'll put it here. Square root of 80. 2 root 15. How you enter that on your calculator is 2 root 15. $7.75 if I round up. So that's approximately equal to $7.75, which I'll put right here, 2 root 15. And the last one is the square root of 0.1. 0.1, which is 32 cents if I round. So approximately equal to 32 cents. That would be 50 cents. So I'm going to go a little less than that. And I'm going to say that's the square root of 0.1. What I would often ask on a test is I would often give you that number line, give you all the numbers, and then I'd say order it from least to greatest. They like to do that on exams as well. So then I just have to now look at my number line and say, okay, the smallest amount of money was the square root of 0.1. Pi is next, followed by the square root of 14. From here, what's next? 2 root 15. And then the square root of 80 is the biggest amount. Okay? So again, think of money, you'll never get these questions wrong. Last question I just quickly want to do, it's a calculator question. So, okay, I'll tell you right now, on a test, so some of you will say, I don't have my graphing calculator yet. I would never ask, what is this as a fraction on your calculator on your first test, because I know some of you won't have it. What I would ask is this rational or irrational, and what's the reason? So I would say to you, okay, 0.36 repeating, you should be able to just look at that and say rational. It's a repeating decimal. But I do want you to know how to type that in on your calculator. So this is, like I said, the advantage, right? So 0.36, enter it a whole bunch of times. I'm not even sure how many we have to enter it in order for it to work, but it always works. 4 over 11. And again, remember, all fractions are decimals. This I know is rational as well, because what this guy is 3.955555, and it just repeats. So let's figure out what that guy is as a decimal. So enter a whole bunch of 5s. Math 1 fraction. 178 over 45. Okay, what I want you to do is turn to page 19 and write skip, or you could just cross out class example 5. They're beyond the scope of our curriculum, changing it to fractions algebraically, like you'll never need to know that. But let's get our homework done. Okay, so for homework, what I want you to circle 1 to 4, so let me write this down. 6 A, B, C, 9 to 12. And I think I'll do 12 with you. Okay, so let's get this circled. So again, number one, go through, write down rational or irrational, and write down the reason why. So talk about the decimals. I'm going to do two of these with you. This guy here, the square root of 49 over 81. So on your calculators, square root of 49 divided by 81, hit enter, gives you this. Go to Math 1 fraction, and it's a fraction. Like it is a fraction. So this, you guys, what's happening here, it's 0.777777. It just keeps going on and on. Remember, like I said, your calculator, when it is repeating and non-terminating, it rounds up. So because it has to stop, on my calculator, it rounded the 7 to an 8. But this is essentially 0.7 repeating, which is equal to, what did we say that was? 7 over 9. So this guy is rational, and the reason is its decimal repeats. That's the reason. I want to show you how to do this guy. If you see a number like this is -4 point, and we need to figure out what 3/8 is as a decimal. So 3 divided by 8. Oh, nice terminating decimal. So 0.375. So -4.375. What kind of decimal is this? So you should be able to look at that and you should say, oh, that's terminating. And all terminating decimals are nice, clean numbers. It's going to be rational. Let's convert this guy to a fraction. So -4.375. So -4.375. If I go Math 1 fraction, -35 over 8. And remember, all fractions are rational, and the decimals of rationals either terminate or repeat. So circle number one. I'd like you guys to do number two. Circle number three, number four. I had number four starred because I always like giving that on a test. Flip the page. Okay, number six. You can only do this if you have the graphing calculator. And it's just like, for example, 0.212121. Can you do this conversion? If you don't have a graphing calculator, that's fine. Remember that I wouldn't actually ask for the fraction on your first test. So 7 over 33. Okay, so number 6. And then let's circle 9 to 12. 9, 10, 11. Oh yeah, I'll do number 12 with you. Okay. Actually, I'll do a couple with you. So number 10, you guys, which of the following is an irrational? If you look at C, fraction and terminating. Fractions are all rational. I know that's going to be not the answer. D, it's terminating. Therefore, that's going to be rational. So I just have to type these two in my calculator, and I've got a Math 1 fraction these. One of these won't go into a fraction, right? And that will be your irrational. This guy, number 11, so we'll do this one together for anybody that doesn't have this on their graphing calculator. So 9.9 repeating. That would be Math 1 10. So 9.999999999. The closest number that that gets to is 10. So that would be the answer for that. Then they say, okay, when the repeating decimal is 0.76, so first thing I need you to realize, sorry, 476, the bar is over this. Okay, so it's the 7.6 that's repeating. So we're going to do this one for those of you that don't have the calculator, so you'd be able to get this. So 0.476, 76, 76, 76, 76, 76, 76. Okay, Math 1 fraction is 236 over 495. 236 over 495. Now, it says when you convert that to a rational number in simplest form, it's going to give you this fraction a over b. So if I said, okay, well, what's the value of a? I hope you guys realize that that's my a value, 236. My b is in my denominator. That's my b value, 495. And what the question is asking is, okay, well, what is b minus a? So they want to know my b value minus my a value. So 495 minus 236. Take a minute, punch that into your calculator. So let's see, 495 minus 236, you should get 259 is your correct answer. Okay? And that concludes lesson 3.